All right, so give everybody a chance to get in. All right, so I guess we will get started. Welcome back. Hopefully y'all had a decent weekend. So last week we were talking about these two things, law of sines and law of cosines. And these were relationships that we use to solve triangles that aren't necessarily easy, nice, right triangles. Okay, so the last one we did, this law of cosines, looks like this in its basic form. C squared, which is a side length, equals a squared plus b squared minus 2ab cosine c. So it relates two sides and the angle between them to the length of the third side. So if you look at how it's set up, so you have two sides A and B, and then angle C tells you something about the opposite side C. But this can be used in any combination you want. So the two sides A and C with angle B tells you something about this side. Or the two sides C and B with angle A tells you side A. So this is how this idea works. Okay, so want to kind of look at something. We want to use what we've learned to try and figure out the area of a triangle. If we have all three sides, how can we use this to figure out what the area of this triangle is? First off, what is the area of a triangle?
Pi squared.
No, that's a circle.
Is it 1/2 base times height?
Yeah. So 1/2 base times height. And this is based on the idea that if you took a box, if you split it into two triangles, well, these two triangles are the same, and so their areas are the same. And they each have half of the area of the box. So base times height would be the area of the box. Half of that is the area of one triangle. So that's where that 1/2 base times height comes from. Let's look at how we can use this fact to our advantage. Okay, law of cosines. We have these three things. We have the length of these three sides. So we need to find the area. What else do we need to find area of this triangle? Or what do we have for the function or the equation for area? What do we already have?
The base.
Base, yeah. So in this case, I drew it so that the base is actually just side B. What is the height of this triangle?
C.
No. So we don't have it, but if I were to draw it, what would it look like?
It would be like a dotted line down the middle of the triangle.
Yeah, so usually they do it with a dotted line, and it's a line, when you have it set up like this, that goes straight down from the peak to the base. Okay, so we're getting a little closer. What does it mean to be straight down from the peak? This one's a little bit more abstract, but you can tell something about how this line relates to this one. That's a very important factor.
Perpendicular.
Perfect. Yeah. So to go straight down, it means that these two are perpendicular to each other. Okay. So now we're kind of getting somewhere. Okay. So let's look at what we've got. So we have A, B, and C. We need to find H. So what about H might we be able to find out? Okay, remember we're using the law of cosines. What is the law of cosines going to give us? If we have A, B, and C, what would we solve the law of cosines for?
We would solve for the sides first.
We have the sides.
So would we solve for the angles then?
We would solve for the angle. What angle, I'm going to write these in blue, because it means we're given them. What angle would be helpful?
I would say angle C.
Okay, why?
Well, because it's like right by the 90-degree, and I feel as though it's something dealing with like that angle being adjacent to. opposite to the H.
So you're definitely on the right track. If we zoom in and ignore everything else for a second, so that's a right triangle, right? Just this side is a right triangle. So because it's a right triangle, if you have A and C, how do you find H? We have A and C, we need to find H. Is H opposite or adjacent to the angle C?
Opposite.
Okay. So we have an angle. We have a side opposite that angle. And we have a side, we have the long side, also known as the hypotenuse if it's a right triangle. What relationship do we know that relates an angle, an opposite, and a hypotenuse?
Is it sine?
It's sine. Sine of angle C equals opposite over hypotenuse, H over A. So H equals, multiply this up, A times sine C. And there we go. So we use the law of cosines to find angle C. And then we know that the sine of that angle equals H. Or sine of that angle times side A equals H. There we go. Okay. So that's how we can use this law of cosines to find the area. Okay. So let's use this law of cosines to find something else. All right. So this is, I guess, a little bit more real world. The pitcher's mound on a women's softball field is 43 feet from home plate. The pitcher's mound is not halfway between home plate and second base. So let's draw this up. So the pitcher's mound is not halfway between home plate and second base. It is not. So what we want to know is how far away is the pitcher's mound from first base. So the side we are looking for is this one. We're going to call it D. So what is D? How can we find that length? So it's obviously going to be a side. So we'll use this version of it, and not the solving for an angle version of it. But we don't quite have all of the information written down yet. We do have all of the information, but we don't have it written. What is another fact about this setup that we know? And it's not some random technical thing that's in the the back of the rule book or anything like that. It's a very straightforward, simple, almost too simple thing that we have to notice, but it is important.
You mean a squared plus b squared equals c squared?
No, because it's not 90 degrees. So if it was halfway between, then this would be a right triangle, but it's not. It's actually a little bit closer to second base than it is to home plate. So we need another piece of information before we can plug it into law of cosines. So we have this side, 43. We have this side, 60. We need this side. So what else do we need? What kind of thing do we need? Do we need the length of a side?
Okay, so would that be a right triangle?
Nope.
No.
Because it's not halfway between home and second base. So it is actually, if it was halfway between and it was right here, then that would be a right triangle. There to there.
So would we use the 43 and 60? Like would those be like A and B, and then D can be like the C squared, I guess,
Okay.
since we're trying to find it?
So, but we need something else. So, what thing did you not mention that is in the equation?
Angle C.
Angle C. So A equals 43, B equals 60. What does angle C equal? First of all, where is it?
It's on the left corner, the bottom left corner.
So
Like-
this is angle C. I agree. What is it?
$30.
It's not 30. So, assuming I could draw, what shape is this?
A diamond. I mean a square, I'm sorry.
A square. What is true about squares? So you're not wrong that it kind of would be a diamond because baseball diamond is a thing, but it's just a square turned on its side.
Right.
But what is true about squares?
Square can be a rectangle.
A square is a rectangle. So what's also true of rectangles?
Is this something about like made up of triangles or something, like two right triangles?
Okay, it is made up of two right triangles, but I think you're getting too detailed. What are two things required for a square? Two things. Give me something that has to be true for the object to be a square.
All 90-degree angles.
All 90-degree angles. So this angle from here to here is 90. So what does that mean about angle C?
It's 45 degrees.
It's 45 because the pitcher's mound isn't halfway back, front to back, but it is halfway left to right. the pitcher's mound isn't like closer to third base or something. The pitcher's mound is right in the middle, left to right. So that means that this angle is 45 degrees. Now we have everything that we need to solve. So you plug stuff in, you get C equals square root 43 squared plus 60 squared minus 2 times 43 times 60 times, what is the cosine of 45?
Root 2 over 2.
Root 2 over 2. So square root of 2 over 2. That means this cancels with this. And if we plug that in, we get 43, 60 plus square root 2. So I get 42.4 feet. So it's close, but it's not exact. So it is actually a little bit closer to first base than it is to home plate. But this is the idea. Do you have law of cosines in your everyday life? So let's ship travels. Trying to think how I want to proceed. All right. So I think we will continue on with this on Wednesday. So yeah. So we'll cut it a little short for today, but please review this law of cosines, law of sines thing, and think about the ways that it can be applied, because it is actually, like I said, these two things are very, very helpful understanding, because you can do a lot with them if you continue on further into math, especially if you get to my class in physics. It'll come up and be very helpful. And it is surprisingly actually very good in if you're going deep into computer science, because a lot of the higher order analysis techniques and stuff like that is actually based on some very interesting geometry. And this law of cosines thing is just all over in geometry. So just make sure you're comfortable with it. There's lots of great examples in the book. Yeah, so we will pick back up with this on Wednesday. And you guys have a fabulous rest of your afternoon. All right. See y'all in a day.
All right, be healthy.
Yeah, y'all too. Stay safe, please.